All right. Hi, everyone. I hope everyone is having a great day at Open Source Summit India today. Yeah. So I think we're good to go. So again, we'll not waste a lot of time between you and lunch. But just a very quick introduction about myself. I'm Shivay. I work at Couchbase as a developer experience engineer. And with me is Sathpal.
Hi everyone, yeah, Sathpal here. I'm cloud and AI architect at UBS.
Yeah, so we are living in an era where everything is being governed by AI, and of course, a lot of different companies have started to build their own MCP servers, and we'll specifically see that how does that correlate. Okay, we'll probably just wait for that to fix. But while that's getting fixed, I'll just give a quick intro about our talk as well. So today in the space or the era of DevOps, where we are seeing more and more complex applications being built, whether it's having 10 plus different microservices. So at the same time, telemetry and being able to ensure that your logs and log generation is also absolutely accurate, that's also something that we have to take into account. And we will see that how we can use an agentic approach and use LLMs coupled with MCP to be able to reduce your overall MTTR or even your incident report management that is very critical to a lot of businesses, and how you can use MCP for leveraging the power of LLMs to be able to debug your entire DevOps life cycles more effectively. So let's first talk about OpenTelemetry. Now, if you look at a typical architecture, we have different types of different agents or tooling that collects different parts of your entire metrics, right? So if you talk about logs, tracing, or even metrics, you have different tooling that you're basically using. And we saw that there's so much complexity having to manage all of these different tools. So this led for us to now use OpenTelemetry. And OpenTelemetry, if you're not already aware, it's one of the fastest growing open source projects within the Cloud Native Computing Foundation. And the entire idea is to be able to unify the different types of collections, whether it's logs, metrics, into one single platform. So with just a single unified approach, you can just collect all of your data, whether it's metrics or logs, and not having to manage a different type of backends, because that, of course, led to a lot of complexity. So it provides you a really high quality and ubiquitous telemetry approach to get much more approachable observability. So if you also look at some of the specific facts, so it's, as mentioned, that it's the second fastest CNCF project only after Kubernetes, and there is no vendor lock-in, so it's completely open source. And it has kind of become the default standard for whether it's logging, metrics, instrumentation. And if you look at the architecture, right, so at the top you have, okay, whether you have the metrics coming from a microservices architecture, or you're getting your metrics from your infra, so whether it's basically your pod logs that you're getting from your Kubernetes. You can basically send all of them to this OTel collector, which is the OpenTelemetry collector. And now you can connect this with any other open source project like Signos, where you can use that to view all of your OpenTelemetry logs. And you can also get a lot of client-side instrumentation thanks to a wide variety of OpenSDK support in Java, Python, most of your popular programming languages. You can export your metrics with the help of the OTel SDKs. So the reason we are basically talking about OpenTelemetry is the fact that as now companies have started to move away from having different types of device architectures, now moving to a more unified approach with OpenTelemetry. At the same time, the application logics and the complexity of the use cases are also growing day by day, which means that the pressure on on-call engineers is growing day by day. We are seeing more and more lapses and probably downtimes for applications because of the fact that there was a miss by an intern, or maybe the entire pipeline, the way that it was designed, was not foolproof. A similar analogy can be thought of with your 100% test coverage when you're writing CI/CD and you want to ensure that all of your tests are being covered. So at the same time, we have already started to see a lot of AI being used specifically for logs, because one of the most important things that we want to ensure is that whenever your application is generating millions of logs, you are not only looking at, okay, are my logs absolutely correct? Is there any anomaly inside of my logs? So of course, you might want to use a state-of-the-art anomaly detection model for your logs, but that itself might still not be enough. And a lot of times companies might not have the required force, like especially machine learning engineers or data science engineers who can write these retrofit AI models that can be trained upon log data. And to be very frank, like log data itself is very tricky to deal with. You cannot just store traditional log data into a SQL or a NoSQL database. You need like time series database and need to make certain enhancements to ensure that you're getting proper logs. So today we'll see that how we are kind of revolutionizing the incident response management as well. So this is also one aspect that we'll cover later on in today's session. But we'll also talk how we can reduce your mean time to recovery when you're analyzing thousands or millions of logs with the help of what we call as MCP. So a lot of you might have at least heard of the term, which is Model Context Protocol. So the entire idea is very simple, that we saw that LLMs are a great way to be able to do a bunch of different things, but they were always not anything but nothing much than text generation output tokens, right? That's what they were capable to do. But we saw that if you're able to pair up your LLMs with tools or external APIs or give them access to your databases, they can do a lot more. They can help you in proactive debugging of applications. They can be used by DevOps engineers to be able to get direct metrics, logs, and of course, it's not just limited to this part of DevOps. You can very easily also use this with CI/CD pipelines or any other different part of DevOps. So the entire idea is that MCP is this protocol that allows AI agents or LLMs to connect with external systems. So whether it's your being able to get access to your logs or an API or a database, and it provides you a very standard way of being able to then send and receive model responses or requests in structured JSON format, and it allows you to connect it with live data. So of course, in a production setup, you'll have millions of logs coming in every second, right? So it can actually, if you have an MCP server purposely built for logs, you can manage all of that log analysis in real time with the help of MCP. And this allows you to build a lot of interactive custom dashboards that give you real-time analysis of your logs and can also be leveraged to connect with external systems like Slack, where you could get real-time Slack alerts or incidents being reported and being created automatically without on-call engineers having to manually now look at your logs and then having to create Terraform scripts to create a Slack alert manually. So you can automate all of that with the help of MCP. And that is why MCP has been extremely beneficial for DevOps pipelines as well. And in fact, like, I'm not sure if everyone is able to see this, but we have seen a huge impact, whether it's with MTTR, being able to reduce the total developer time that they have to spend debugging these logs, and there are statistics anywhere between 20% to 50%, especially coming from a lot of these different companies that are working in the observability space, so like especially quoting some of the open source ones like Signos, where they have specifically mentioned that how MCP adoption has led reduction in the MTTR, but also in developer productivity. And developer productivity, especially for DevOps teams, is highly critical because you don't just want your half of the DevOps teams trying to debug just naive issues that could have been automated with the help of AI. So we have seen a lot of different impactful things that are happening with MCP, and this has led to adoption of a lot of different open source projects also incorporating their own MCP servers. So whether you talk about Kubernetes, today you can use Kubernetes MCP server to not just interact with Kubernetes clusters in natural language, but also diagnose them in natural language. Similarly, if you're talking from an OpenTelemetry space, we have MCP servers for Prometheus, for Grafana, and that is why, it'll be a good segue for me to let Sathpal take over, who will kind of walk you through what exactly is the Grafana MCP server and show you like a real-life use case for production, where you'll be able to see that how you can use the combination of OTel, MCP, and do real-time log analysis.
Just a mic. Hello. Yeah. All right. Thanks for the great insights. Okay. I'll talk about the Grafana MCP server. Now, while working on the observability, I get a lot of questions that how now we have so many tools. We have ChatGPT, but how to bring the context of our Grafana server into the chat so that we can have conversational observability, right? So I think, of course, we all are hungry now, but production incidents keep us more hungry, right? So, I'm going to demo how we can converse with our Grafana server. Check the CPU or logs. We'll have some simple example where we'll see the my ChatGPT will get the CPU memory from my cluster, and it will create an incident if the threshold breaches, right? So I'm going to show that. Now, just of course, Shivay has given the idea about MCP. What does the Grafana MCP do? Now, it's an open standard by Grafana Labs. It's an open source software. Anyone can just use the MCP servers. It's already running on my local. I'll show it. Apart from that, the Grafana Labs have also introduced AI assistants. It's only with in a beta version. It will be enabled on request, and it connects the LLM-based agents. As I was saying, right, we can connect with ChatGPT, Perplexity. I'll show that as well. Yeah. And the agents with the observability platforms like Loki, of course the Grafana server, but for logs Loki, for metrics Prometheus, for traces Tempo, right? And enables AI interpret, query, and act on metrics, logs, and traces, right? So AI, as you know, right, we give some prompts, we get the answers, right? It's the same way it interprets the data from the Grafana server, gets the context, and it will explain, let's say, if the CPU threshold has breached. It will explain us the steps, why it has breached, what remediation steps we can take, right? Now, it powers use cases like chat-driven observability and automated incident response. Chat-driven observability, as I was saying, right, it can interpret the metrics, logs, and traces. Now, automated incident response, it creates an incident based on the threshold breach and also creates a channel on Slack, right? So that the on-call engineers, as Shivay was saying, right, it saves times. It saves the time for the engineers to create a channel manually. And once the channel is created, anyone in the workspace can join the channel and work upon the issue. And there are quite a few interesting tools from Grafana MCP where you can update the RCA using the add activity tool. While chatting with the, in the context, while chatting, you can, in fact, tell the tool to update the RCA. In fact, it goes and updates the RCA into the Grafana incident, right? I just like to have a simple diagram. This depicts the demo. User with the prompts chats with the LLM models. We have ChatGPT, Perplexity, Meta. You can, in fact, bring in your own LLMs, AI assistants, which can connect to Grafana MCP, and they can chat with your Grafana servers, right? So, of course, the chat LLMs contact with the Grafana servers, which is running on SSE mode, server sent event mode, and it's written in Go language. And we have many servers. I'll show you. We have MCP Grafana server, Loki server, MCP K6 server, MCP Prometheus servers. In fact, you can create your own MCP server with the Model Context Protocol SDKs, which is officially provided by the Model Context Protocol documentation. You can create your own MCP servers, add it to there's a MCP Super Assistant, which was launched like a couple of months back, which is a great tool. I'll show you how it works, right? Once we have the server into context, we need the Grafana server API key to connect to the Grafana server. It can be viewer role, editor role, or admin role. Based upon whatever you want to have the access for the user, right? Okay. So before this, I would like to go for the demo. So here's my MCP servers running on my local, right? You can see the server SSE session. So the session is in context. We have three servers running here. I can show the config file. So we have MCP Grafana, we have Prometheus server, we have Loki, and we have K6, all running on my local in a single, with a single command. So MCP super assistance provide us we can leverage the assistance to run the MCP servers in our local, or you can host it anywhere on Azure or EKS, anywhere, and then you can also have remote server access, right? So without much ado, I will play the demo because it's gonna be quite tricky if I chat it. Okay. All right. So my MCP is running on the local. You can see the tools have been loaded here on the right-hand side. So this is the server running on my local. And when I open ChatGPT, the MCP Super Assistant has loaded all the tools and brought the context of my Grafana server. Now let's see how it responds. So I need to load the instructions into my chat that is bringing the context of my Grafana server here. And I'll say list the Grafana data sources. See, it has fired list underscore data sources. That is a tool provided by Grafana MCP. And in the JSON format, as Shivay was mentioning, right? Everything is in JSON format. See, it has got, I have a Grafana cloud server with me, which has so many data sources. So this is real time. This is real time, it's getting the data sources. Now, my application is hosted on AKS. I'll just for showing, we have 2 nodes here. We also have LGTM, hotel LGTM running. The hotel is collecting the logs, traces, metrics, and it has created the data sources as well, as you can see in the list. Simple layman language, I want to know the CPU and memory of utilization of my cluster. In fact, I'm telling in the chat that if the threshold has breached, create an incident with explanation. Now you'll see the magic here. You see, it's explaining the metrics queries as well for you. And this is all real time. Now it says the CPU is within the threshold. That's fine. So it's again querying, getting the matrices. Now it got the values for the CPU memory. See, the node, it displays the name of the node. Now it checks the threshold for the memory. See, above threshold, right? So it's creating an incident instantly. So you need not tell an on-call person or ASR or SRE to go and create an incident. It's automatically creating for me. In fact, if there is an error, I just chatted the same error, it's fixing the error. Sometimes it happens, right? We miss a quote, something in the JSON, right? But here, I'm just pasting the same error to the chat, and it's fixing the error. It had, a couple of times it happened, but ultimately, it created. This will come soon. That's fine. So these tools are still evolving, but you need to understand, to have a foolproof tool as a chat tool, you need to run prompts. Again, remember that it stored the context of the chat. So whatever you are giving the prompts, don't give a vague prompt, else it will just give you maybe it will go into wrong direction. It will not give you the desired results, right? See, it has, by standard, there are some labels, but it has not found a label on my cluster. So it's checking what are the available labels, and then it is querying and getting the data, and then it will create the incident. See, incident is created. Now I'm creating a dashboard out of it. See the beauty of these tools? I need not go to Grafana UI and put this query into the panels and save the panel, save the dashboard, align the panels. Now you see the magic. It will. I'm also telling that create a dashboard for CPU usage, memory usage per node. It will also suggest me whether I want to go for pod utilization or not. See, add more panels, disk, network, pod level status. So I'm greedy, I want more panels, right? I want to see the cluster utilization, pod utilization. So I say, yes, go for it. Now let's see whether it has created the dashboard or not. It will come, it's still running. Yeah, it has created. We got the success response here. Let's refresh the instance. Voila. See? It hardly took 10 minutes for me to investigate the metrics, logs, or traces, create an incident, and create a dashboard out of it. Now the beautiful part here is, we'll check whether the incident is created upon the high utilization of memory. Yes, it has created. Wonderful. Now we'll go to Slack and see whether the channel has been created or not. So it's redirecting directly to the integration between Grafana and Slack is already there. So let's see whether it has. See? Within a time span of less than 10 minutes, we have investigated an incident. We have created a dashboard out of it. We have created an incident and then post that incident to a Slack channel. Like so on. So we can create, if you want, we can enrich the dashboard by creating more and more panels. Or likewise. I'll just stop this demo and quickly show. Yeah. Yeah, that was a demo.
And basically, as you were, yep. So I know we are running out of time, so I'll keep this very brief. But yeah, thanks Sathpal for that amazing demo. But of course, as you saw that this was more of like a chat GPT kind of an experience. So of course, in real time, what you would basically have is a backend application that's sending in the hotel logs. You're collecting them with the help of a deployed Grafana MCP server. And from there, you can basically get these logs. And you saw that there is a dedicated MCP tool that allows you to create a Slack channel alert. So you can just automatically call that. You can define that entire flow, and it will help you to create notifications on Slack, or if you want to create like a PagerDuty one, if there's a different priority. So you can also configure your entire MCP server in such a way that you define the different priority orders based on your company's SRE goals, right? And you can customize this MCP server. And the fact is that, of course, we showed an example with Grafana, but of course, this is open source summit, so there are a bunch of other different open source tools that are working on OpenTelemetry, and you can also use them. We just wanted to quickly show you an example of Grafana because that's one of the most configurable. And in fact, I think a lot of companies are also actually starting to use the same MCP server in their own companies. So I would highly recommend you to try to follow this kind of an architecture in your own company to be able to like automate a lot of these different things that you saw that we demonstrated with example. Now, there are some other alternative approaches as well. Now, the idea is that you can leverage something called as vector search. So the entire idea is, imagine that you have a bunch of incident reports that you have created, and you have Jira tickets with the resolution of all of these different tickets. So how you can enrich your DevOps agent to be able to respond to user queries based on historical data of what has already happened in the past. So that's where you can basically use different types of use cases. Of course, this might not be visible to everyone, but let me give you like a very high-level approach of basically what's happening behind the scene. So what we have done is that we have taken a historical data of different Jira tickets for different incidents that had been reported regarding your DevOps architecture, and we basically also have the solution of how those were resolved. And then all of these were ingested into a vector database. So you can use whatever open source vector database that you want. And in this case, now what will happen is that as soon as a new incident has been created, so rather than the DevOps team trying to spend a lot of time manually debugging what's happening, you can now just ingest that new incident to your RAG, so that's retrieval augment generated, or with an MCP server, and it can very quickly look at all of your previous incidents that you have created and their resolution, and it will compare that with the current context of this new incident, what is the most closely matching incident that you have received in the past, and you can now very easily find that similar type of incident and how we had responded and what were the resolution steps. And now you can apply the same similar type of resolution steps for this new incident and create an automated incident report management. So that is why you'll see that here, if I zoom in a bit more, right, you can go ahead and retrieve those similar type of incidents and get auto resolution. Or in the case that the agent was not very comfortable or was not confident, you could just now again go ahead and create a Slack alert with the Grafana MCP server. So this way we are showing you that how you can incorporate MCP and agentic use cases for being able to resolve all of these different problems in real time. And of course, I'm sure, like Sathpal, you can probably convey that the SRE agent that you basically showed with the MCP server, you're already using it at UBS, right? So we are already seeing companies adopting these type of MCP servers in production. In fact, like at Couchbase also, we are having a Kubernetes MCP server that allows us to debug our Kubernetes cluster. So we're already seeing these in real time, and they are, of course, not 100% foolproof, but they are getting good enough that you can start to use them in at least, like, let's say, if not in production, in your staging environment and your dev environment. But yeah, with that, we'll conclude. If you have any questions, we'll be here. And these are our socials, so you can connect with us on LinkedIn. But yeah, we'll be here for the rest of the day to answer any questions. Thank you so much.
Yeah, thank you so much.